Hello everyone. Today I am going to discuss the 50th question of 2018 physics paper. So let's move on to the question. A, B, C and D represent vertical cross sections of four identical parallel rectangular metal plates placed normal to the plane of the paper. So you can see they are placed normal to the plane of the paper. Each of the plates B, C and D has a small hole at its center. The three plates are arranged so that their holes are coaxially placed as shown in the figure. That means there are three holes, they are coaxially, that means in the same line. Plate A is grounded, that means voltage is 0 and the entire system is in a vacuum. A stationary electron is created at time 0 at the position O on the axis through the holes as shown. Which of the following voltages VB, VC, VD should be applied to the plates to obtain the velocity time curve shown in the figure? And assume that the given voltages are suitable for practical use and that the edge effects and gravitational effects can be neglected. So here you can see there are four plates A, B, C and D. They are placed parallelly and there are three holes in B, C and D. In the question they have told us that an electron is produced at the plate A and it has gone in the pathway as shown in the figure B, velocity time curve. In that velocity time curve there is the area of that velocity time curve is first in the positive side and then in the negative side. That means if the electron is going towards the right side of the plate A, it is positive. Then minus side of the velocity time curve means the electron has come the other pathway. So we can see the pathway of electron is ABCD and then DCBA. That is normal. Now let's move on to look at this. You can see there are P and Q plates. In P plate there is a high voltage or high positive ions, and in the Q plate there is a low voltage, or in other words negative ions. If an electron is taken, you can see for an electron the pathway of going from a positive voltage to a negative voltage is a somewhat difficult process. Why? Because there is attraction by the positive ions and there is repulsion from the negative ions. So for an electron going from a positive voltage to a negative voltage is somewhat difficult. But in the other hand, in the other way, it is easy for an electron to pass from a negative field to the positive field. It is repulsed from the negative plate and it is attracted by the positive plate. So it is easy. So for a proton, it is the opposite. Here we can see an electron, we can see that from a positive voltage to a negative voltage, or from a positive voltage to a lower positive voltage, for an electron to pass by, the pathway or the process is difficult. Here in the velocity time curve, the first part is an acceleration, second part is deceleration, and the third part and the CD part is deceleration, but the magnitudes are different. You can see B, C and D pathway. If you take the pathway from B plate to D plate within the C plate, you can see there is all deceleration. Deceleration means the electron has gone with some difficulty. That is why it is decelerating. So we can see the highest positive voltage or highest positive ions should be in the B plate and the lowest voltage should be in the D plate. Why? Because now I am considering only the B to D pathway. In the B to D pathway, the positive voltage, the highest positive voltage should be for the B plate and the lowest voltage should be for the D plate. Then electron will come decelerating from B to D. That is normal. And as we can see, the highest magnitude is in the CD pathway. That means it depends on the voltage difference. Imagine if the voltage difference is very high, then the electron will go more having a very difficult, that means having a more difficult process for electron to pass to the C to D. That is why it has the highest magnitude of deceleration. And then in the BC there is a deceleration, but it is low in magnitude. If the magnitude is low, that means we can say voltage difference is low. AB plate, there is a magnitude in between Y and Z. So as I have shown in the red color, the voltage difference between CD plate will be the highest. That is why it has the highest magnitude of deceleration. Then the highest magnitude of the acceleration, highest magnitude of the acceleration in the velocity time curve represents the second highest voltage in this in between plates, that is X, and the lowest voltage difference between plates will be Y. I have given X, Y and Z for the voltage differences between plates. So we can see, when we look at the answers, the voltage differences from CD, BC and AB, we can calculate AB by A is 0 and B is the given values, and BC and CD we can compare those. And as we have taken now, the highest voltage difference is Z, then X, then Y. We can exclude 1 and 2 and 3 answers. First 3 answers can be excluded. Then we will have only 4 and 5. In the 4 and 5 you can see VB is positive 3, and the only major difference there is the value of the VC. It is positive 2.6 and positive 3.2. I have told you, for this electron to go from B plate to the D plate, there should be a voltage difference having the highest voltage on the B plate towards D. I hope you understand. Then electron will be moving with difficulty from B to C, and even with more difficulty from C to D. That is the one depicted in the velocity time curve. Acceleration means the acceleration of the AB plate is in between the magnitudes of those decelerations. That means the voltage difference is in between Y and Z, and on the other hand, the voltage difference in the X should be between Y and Z. So in the 4th and 5th answers, the VC will be 2.6 and 3.2. Imagine if VC is lower than VB, what will happen? The electrons will be having a more difficult situation to pass from B to C. Imagine if VC is 3.2 and VA is 3, there is a voltage difference having the highest voltage in the C plate. If it is having on the C plate, the electron will be easily moved to C plate from the B plate. So there won't be a deceleration, it will be an acceleration. So we can see, for the movement between B and C to be a deceleration, we should have higher voltage in the B plate and the lower voltage in the C plate. So the answer is number 4. If you summarize it, for an electron to move easily, it will go from a low voltage to a high voltage. From a high voltage to low voltage, electron finds it difficult to pass. This is the main theory. So from B to D, there is a deceleration. So electron is moving with the difficulty. So that means highest voltage at VB, and then C, and then D. That is descending. From A to B, there is an acceleration. So there should be low voltage in the VA and high voltage in the VB. That is it. It is not difficult if you get these things clearly.